Right, we're doing question 4.1. Sketch below is the graph of h of x equals 1 over x plus p plus q. The asymptotes of h, that's the hyperbola here, and intersects at 1 and 2. So those are your two asymptotes. 4.1.1, write down the values of p and q. Okay, so p and q are simply your asymptote x and y values respectively. So if we look at p, it'll be the horizontal, the vertical asymptote. So p is equal to minus 1. Look at your vertical asymptote. And the reason it's minus 1 is everything to do with the x's in this standard form goes to the opposite of what you think. And your q is going to be the horizontal asymptote there. So q is just going to be equal to plus 2. This particular asymptote in standard form, it is what you think. It works exactly the right direction. So again, the vertical asymptote is the x value of the asymptote, and the horizontal asymptote is the y value. Okay. Number 4.1.2, calculate the coordinates of the x-intercept of h. So the x-intercept of h is over here. Just like anything, in order to find the x-intercept, you let y equal to 0. So we'll have, here I just subbed in the p and q values. We have 0 equal to 1 over x minus 1 plus 2. We want to take that 2 across and say minus 2 is equal to 1 over x minus 1. And now we have one term on each side, so we can times both sides by x minus 1. So minus 2 x minus 1 equals to 1. Obviously, it would cancel out on the right-hand side. Here we have minus 2x, just timesing the brackets out, plus 2 equals to 1. We want to isolate x, so minus 2x is equal to 1 minus 2 minus 1, and divide by minus 2. So we end up with those cancelling out, the 2's cancel out, and we get x is equal to a half. Now just to check back with your question, calculate the x-intercept. So it doesn't want just what x is, it wants the actual x-intercept. So the x-intercept would be a half 0. Number 4.1.3, calculate the x-coordinates of the x-intercept of g if g of x is h of x plus 3. So that's h of x that has been shifted by 3 units to the left. So how can we work this out? Well, if h of x is 1 over x minus 1, then h of x, our new g of x, is equal to h of x plus 3. So h of x plus 3 is just wherever you see an x, you now have a x plus 3. You just substitute the x plus 3 for x. Quickly solving for this, we have 1 over x plus 2 plus 2. The question asked for write on the x-coordinates of the x-intercept. So the same method applies as before. To get the x-intercept, you let y equal to 0. 0 equals 1 over x plus 2 plus 2. Minus 2 equals to 1 over x plus 2. We times out both sides by x plus 2. Minus 2 x plus 2 equals 1. Then we get rid of the brackets. Minus 2x minus 4 equals 1. Take the 4 over by adding 4 on both sides. It'll be 5 equals to minus 2x. Now we want x on its own, so we divide by minus 2, we divide by minus 2. So x is equal to negative 5 over 2. It just wants the x coordinate of the x-intercept, so just the x. That's complete. 4.1.4, the equation of an axis of symmetry. So an axis of symmetry of a hyperbolic function either this way or this way. This one had y equals to x plus t. So it's the positive axis of symmetry. So it's this one. It's the y equals to x is the axis of symmetry, but it's been shifted up or down by a value of some sort of value, which they've called it the unknown t. It's saying, what is this unknown t? What is the unknown t? So we look at our equation here, and if you look at the point where the two asymptotes meet, this point here is the x value is 1 and the y value is 2. So 1, 2. The point where the two asymptotes meet is actually a point on this axis of symmetry. So this is our y equals x plus t. This is our axis of symmetry, which means that it's symmetrical if you fold your page this way. And it's been shifted up by a certain value, and we have to figure that out. So the way we can do it is just get your usual equation for a line, y equals mx plus c. And we know that m is 1. It was given. So m is 1. So it's y equals x plus c. So the only unknown parameter is still c. But now we can sub in this value, 1, 2, this point on the axis of symmetry, that is the crossover point between the asymptotes. So we say sub point 1, 2, and we have 2 equals 1 plus c. So therefore, our minus 1 from both sides to find c. So c must be equal to 2 minus 1, which is 1. C was in the position of t, so therefore t is equal to 1. Number 4.1.5, determine the values of x for which minus 2 is smaller than and equal to 1 over x minus 1. Okay, so for this question, we want to get x on its own. So one thing we could do is bring the 2 over to the right, so by adding 2 on both sides. Oh, excuse me. And just to remember that this is a inequality, so if you divide or by a negative number, or if you times by a negative number, this inequality sign will turn around, so just be aware of that. But currently we didn't divide, we added 2, we didn't divide by anything. We need to find a lowest common denominator here. Our lowest common denominator is x minus 1. So this term stays the same, it's just 1 over x minus 1. 2x minus 1 over x minus 1 would give the common denominator there. And of course, 0 over x minus 1 is still just 0. So we end up with 0 equal to 1. If we drop the denominators now that they're all the same. 0 equal to, excuse me, we don't want to drop these denominators because we're trying to work out all the options for x. Trying to work out all the options for x. Don't drop the denominator there. So we have 1 plus 2x minus 2, all over the common denominator of x minus 1. This is also x, just keep that there for now. Okay. Simplifying this a bit further, minus 2 plus 1 is simply minus 1. So we get 2x minus 1 over x minus 1 is larger than or equal to, this doesn't make any sense, it's 0. So here we have a multiplication or division equal to, equal to a 0. If we take the critical values of it, if we split this, we can split this up. So we can say that 0 is smaller than or equal to 2x minus 1, or 0 is smaller than or equal to x minus 1, because one of these has to be 0. 0 divided by 0. One of these has to be 0 in order for this to be true. Okay. Final step, we can take the 1 over the equal sign. Again, we're not dividing by 1, we're plussing 1, so it's just 1. And you divide by 2. Divide by 2, it doesn't change the sign over. Here, also, you're just putting 1 onto the other side, so plussing 1 on both sides, it also doesn't, the sign stays the same. But this isn't quite complete, because we had an x minus 1 in the denominator, and your denominator cannot be 0. So there's a requirement that x minus 1 cannot be equal to 0. Therefore, our x cannot be equal to 1 if you take that 1 over the... So the correct answer doesn't include the equal sign on this side. It only includes the equal sign on this side. Number 4.2. Graphs of f of x and g of x are over here. E and h are the x-intercepts of f. So E and h are x-intercepts. This is the x line. C is the y-intercept of g. And the two graphs intersect at D, the turning point. So this is a turning point over here. Question 4.2.1, write down the coordinates of C. So C, what is C? Well, C is the y-intercept of f. So y-intercept, you let x equal 0. F of 0 is 0 squared minus 4 times 0 minus 5. So the y-intercept will be minus 5. Y will be equal to minus 5. Question, write down the y coordinate of C, just one of the y coordinate of C, so that is minus 5, but anyway, if we want to write it in here, the coordinate would look like this. Determine the coordinates of D. So now it wants the full coordinates of D. D is the turning point of f. F is a parabola, it's a quadratic function. So in order, from standard form, you can use minus b over 2a in order to find the x of the turning point, the x. So there's some sort of xy over here. In order to find that x, we use minus b over 2a. Just make sure that your function is in standard form. So we had x squared minus 4x minus 5. Minus b over 2a would be minus 4 minus b over 2 times 1. and put this, it would be plus 4 over 2. So it'll be equal to 2. This will be to get the x of the turning point. In order to get the y of the turning point, we can sub our x value back into the original equation. So f of 2 is equal to 2 squared minus 4 times 2 minus 5. And this is 4 minus 8 minus 5, which comes to, this is 8 and 5 is 13. 13 is negative 9. Therefore, our d is, the x value is 2, and the y is negative 9. So our turning point is 2 and negative 9. Question 4.2.3 is to determine the value of a and q. Our a and q are over here, so they're in G. So G is some sort of exponential equation. And an exponential equation in standard form, your q value is just going to be the y of the asymptote. So if you look at G here, the asymptote is actually the line that goes through point C. So that asymptote, the information was also given. Yes, it's the C lies on the asymptote of G was given. So Q is just by inspection is going to be the minus 5. So we already have that. Then we end up with still one unknown, is the A. And to get rid of one unknown, oopsie, let's just put the actual value for Q. We would, to get rid of one unknown, we just need one extra piece of information. For each unknown, you need one piece of information. So I want to sub in this turning point here, because that is also on G. So the point D is on G. So if we sub D, from the previous question, we got that turning point, we sub that into G of X, then we can solve for A. So if it's minus 9 equal to A times 2 to the power of 2 minus 5. So we just have to simplify this. Minus 9 plus 5 is equal to, we plus 5 on both sides, A times 2 to the power of 2, so A times 2 to the power of 2 is 4. Divide both sides by 4, we end up minus 9 plus 5 simplifies to minus 4. So it's minus 4 over 4 is equal to A. A is therefore minus 1. It just asks for A and Q, so you don't need to write the equation out again. 4.2.4, write down the range of G. The range of G has to do with the y's, the y values. So here's our G. And the y's of G can only go from the asymptote or down, from the asymptote or down. So the range of G is that y is less than the y of the asymptote, which is minus 5. The y values are going to be less than the asymptote. And y is an element of a real number. So y is anything below the asymptote, not including the asymptote, and it's a real number. 4.2.5. Determine the values of k for which f of x minus k will always be positive. F of x minus k will always be positive. So let's look at f of x. F of x is this. In order for f of x to always be positive, it's going to be some sort of vertical shift. So it's going to go up or down. And for f of x to always be positive, We need to look at what sort of shift has happened for f of x minus k. F of x is x squared minus 4x minus 5, and we're minusing k. So saying, well, what value does this k need to be in order that the y values of f of x is the y's of f will always be positive? Well, I look at the turning point and I realize that this turning point has to go up to 0 for the y's to always be positive. So therefore it's a vertical shift. It's a vertical shift up by 9. It's a vertical shift by 9. So our k has to be smaller than minus 9. Has to be smaller than minus 9. As soon as it's larger than minus 9, then we go back into having these negative y values, which was not wanted. Right, that concludes question 4. Like if you like and subscribe.